Let's see how we can quickly get the magnetic field intensity of an infinite line of current using Ampere's circuit law. Let's position the current flowing along the z-axis, and let's pick a circle for our Amperian loop, and we will integrate in the a sub phi direction. So dl along our Amperian loop will be rho d phi in the phi direction. From our iron filings around our wire, we know that the magnetic field intensity will only have a component in the phi direction, and it will only depend on rho. This is because if you move in the phi direction, nothing changes, and if you move in the z direction, which is out of the page, nothing changes. But if you move in the rho direction, the field falls off. So for H, substitute the form of our magnetic field intensity, and for dl, substitute rho d phi in the a sub phi direction. The current enclosed is going to be I, because if you put the fingers of your right hand in the direction of your integration, your thumb points in the z direction, and the current flowing in that direction is I. So a phi dot a phi is 1, so this integration becomes h rho d phi is equal to I. You're only integrating with respect to phi, so to go around your Amperian loop, you're going to integrate from 0 to 2 pi. Since rho is constant when you're on this Amperian loop here, h and rho are constants that you can move outside of the integral. So you have h times rho, integrate from 0 to 2 pi, d phi is equal to I. So this integration will give you a 2 pi. So we have 2 pi rho h is equal to I. So solving for h, you find it is I over 2 pi rho.